Yes, so hello everyone. This is lecture 4 on discrete mathematics. So in this lecture, we are going to start predicate logic. Okay, so first of all, we should know what is predicate and then obviously we will start predicate logic. Okay, so predicate is a proposition function. Okay, predicate is a proposition function and it is not proposition itself. Okay, so predicate is not a proposition, but it is a proposition function. So what is a proposition function? Let me give you a small example. See this example. Okay. Ex. Ex is a proposition function and what it is saying x plus 2 is equal to 5. So now please see carefully. X plus 2 is equal to 5. This is not a proposition. Why? Because it entirely depends on value of x. If x is 3, then this value, its truth value will be true. If x is not equal to 3, then obviously its truth value will be false. So it entirely depends on the value of x. So it's not a proposition. But if we see this px as a function, then obviously it is a proposition function. So this is a proposition function, and proposition function is not a proposition. You should remember this thing. Okay. So now you can supply value of x and you will get the answer. For example, in normal function, what we are doing the same thing here itself. Okay. For example, I can find p2. What is p2? 2 plus 2 is equal to 5. Okay. P2 is what? X, you take x is equal to 2. P2 means you take x is equal to 2. So it will become 2 plus 2 is equal to 5, which is clearly false. P3, 3 plus 2 is equal to 5, which is clearly true. P4, 4 plus 2 is equal to 5, which is clearly false, and so on. Okay. Yes, so you can take, in place of x, you take any value. Now, if you take P2, P3, P4, all these are, I think you have got it, all these are propositions because we can assign a unique truth value to them. Okay, so all these are propositions. So P1, P2, P3, P4, and so on, all these are propositions, but Px is not a proposition, it is a proposition function. Okay. So now the question arises how proposition function will become proposition. Our aim is to make it a proposition. So what are the ways to convert proposition function to proposition? So there are clearly we have two ways. First is give any value. I have already told you P2, 2 plus 2 is equal to 5, P3, 3 plus 2 is equal to 5, P4, 4 plus 2 is equal to 5, and so on. So you just give any value, you will get the answer, you will get your proposition. This is one first way. And the second way is quantifiers. Okay, so quantifiers are for all and there exist. I will tell you after few slides what are for all and there exist. Okay, please take snapshot. I will jump to the next slide now. Okay, so I hope you have taken it. I'm jumping to next slide now. Yes. So now the question arises. See this. I am taking some value, na? Like for example, I am taking x as 2, 3, 4, and so on. So I have written giving some value is okay. But value will come from where? That is the question. Okay, so from where this value will come? 2, 3, 4. From where these values are coming? So these values are coming from the domain. So for example, px x plus 2 is equal to 5. Now I can set the domain. Domain means some set of values. So I can set the domain as real numbers. I can set the domain as integers, positive integers, negative integers, positive real number, and so on. Whatever domain I want to set, I can set it. Okay, so for example, px x plus 2 is equal to 5. So domain can be integers, domain can be real numbers, and so on. Okay, so what is the domain? Domain is set of values. So I think you have got it. So in the previous slide, I have given you how to make proposition function as a proposition. So one of the way was give any value. So I can give any value 2, 3, 4, and so on. But from where these values are coming? From where these values are coming? These values are coming from the domain, and domain is what? Set of values. So domain can be real numbers, integers, positive integer, negative integer, and so on. Okay. Now, if for numbers, okay, we are talking about numbers here. Na? X can be any number. So if this is very important point, okay, please try to concentrate. If domain is not given to us, if domain is not given to us, what domain we will take? We will take real number as a by default domain. Okay. If for numbers domain is not given, then by default you take them as real numbers. This is very important point. Okay. So in GATE exam, sometimes they won't give you the domain. So in that scenario, you will take it as real number. So for the numbers, we can take domain like this. Okay, but what if numbers are not there? Okay, in proposition functions, we are not supplying the numbers. Let me show you that in the next slide. Please take snapshot. I will jump to the next slide now. Okay, I'm jumping now. See this. X is a student in your class. Px is X is a student in your class. Okay. So now this X is an object. Okay. So for objects like school, class, friends, and so on. So anything which is not number, you can consider them as objects. Okay. Anything which is not number, that is object. So when we are talking about something which is not a number, then what should be the default domain? That is the question. Okay, if we are talking about numbers, then the domain is real numbers. But if something is not a number, okay, like student, school, class, friends, and so on, anything, so not a number. Objects means not a number. When something is not a number, then what should be the domain? That is the question. So in that case, domain will be your entire universe. Okay. If for objects domain is not given, then by default take entire universe as the domain. Okay. So for the numbers by default you will take real number as the domain. And if something is not a number, not numbers like student, class, school, friends, etc. That means some objects are there. So you will take entire universe as the by default domain. I hope I have made the point clear. Please take snapshot. I will jump to the next slide. Yes, I'm jumping now. So now I have discussed about this thing. Give any value. Okay, I have shown you na how proposition function will become proposition two ways. Give any value. I have shown you. Now I am going to tell you about quantify. That is for all and there is. Okay. So what is the meaning of quantify? I have already told you like Px such that x plus 3 is equal to say 5 and so on. I have given you some equation like that. Na? Yeah, x plus 2 is equal to 5. Okay, anyhow, you can take any equation like this. So from where this value of x is coming, I have told you this value of x is coming from the domain. Domain is nothing but your set of values. For example, real number, integers, and so on. So forget about all these things. You just consider this is the domain or set of values. Okay. This is the set of values or domain I have taken. Now, what do you mean by for all xpx and what do you mean by there exists xpx? So let me show you. For all xpx means for each and every value in the domain, the proposition function must be true. So for all xpx means for all values in the domain, as the name suggests, for all values in domain px, that means proposition function must be true. For all values of in domain, proposition function must be true. So now, for all values means what? So mathematically, if I want to write, I will say like this: p of x1. Say these are the values in the domain. So let me label them as x1, x2, x3, x4, x5, and so on. Dot dot dot. Okay. Yes. So I will say p of x1 and p of x2 and p of x3 and p of x4 and p of xy dot 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 dot. Okay, it should be true. So for so when px1 is true, px2 is true, px3 is true, px4 is true, and so on, all will be true. Obviously, then for all x, for all x px will be. I think you have got it, na? And this is true, this is true, this is true, this is true, this is true. All of them are true. Then I will say true and true and true and true and true and so on. It will be true. But if one of them is false, then obviously and will give us false. I think you already remember the truth table of and all these kinds of things. I'm not going to explain all this basically. And means whenever at least all the inputs are true, only then it is true. Okay, if one of them is false, then obviously it is false. So I have told you all this. Okay. So I think you have got it. For all x px means px1 and px2 and so on like this. Now there exists x px is true means what? For some value or for at least one value. Okay, what does this mean? For at least one value, in domain, proposition function is true. So proposition function is true for at least one value in the domain. There should be at least one value for which it is true. Then I will say okay, there is this x px is true. So mathematically, how I will write? At least one of them should be true, na? So obviously px1 or px2 or px3 or px4 or px5 and so on. Dot 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 dot, dot like this. So now let me say px is x plus 2 is equal to 5 and the domain is say integer. Let me show you here. Px is x plus 2 is equal to 5 and the domain is integers, or you can say domain is positive integer. Let me say like, okay. So in domain values are 0, 1, 2, 3, sorry, positive na, so I will not consider 0. I will consider 1, 2, 3, 4, 5 dot 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 dot. So what I will say? I will say P1 is true, either P1 is true or P2 is true or P3 is true or P4 is true or P5 is true dot 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 dot. So even if one of them is true, I will say okay, it is true. So for obviously na, when x is 3, this is true. Rest everything is false. No problem. In case of or, even if one of them is true, answer is true na. So there is this text Px will be true. I hope I have made the point clear. So at least one value in the domain, if proposition function is true, then I will say there is this x px is true. But for all x px to be true, I have to say for each and every value in the domain, it should be true. So clearly here for all x px is false. Why? Because I have shown you only one value to be false. Even if I have shown you one value to be false, immediately I will say for all x px is false. That's it. So I hope I have made the point clear. Please take snapshot. I will jump to the next slide. Now everything is on one slide. Please take snapshot. Okay, now I'm jumping to next slide now. So now I will show you some questions. So first is Px x plus 2 is equal to 5 and domain is integer. Clearly x plus 2 is equal to 5. This is not a proposition. I have told you many times this is not a proposition because it entirely depends on the value of x. When x is 3, then it is true. When x is not 3, then it is false. It is not a proposition. So my question is, are all these propositions A, B, C, and D option? All these are propositions or not? For example, I will say for all x px. Now domain is set to integers. So for all x px will be true when for each of the value in the domain it should be true, and it will be false when even one of the value it is false. So obviously here I will say clearly it is false. So I am able to assign a unique truth value now. Obviously these all are propositions. So all of them are propositions. So that's why I have told you. See this. So two ways give any value and quantifier. As soon as I apply quantifier, it will become proposition. Okay, so proposition function will become proposition whenever I will apply for all x or there exist. Okay, so for example here px x plus 2 is equal to 5. That is a proposition function. It is not a proposition. But if I apply for all x px, immediately I will say this is a proposition. Or there exists x px, immediately I will say it is a proposition. Why? Because now I can assign a unique truth value to them. So for example, if domain is set of integers, so for all x px clearly it is false. There exists x px, clearly it is true because there is some value of x in the integer set for which this equation is true. Obviously it will be true. So I hope I have made the point clear. So I am able to assign a unique truth value to these things. So these are proposition, but px this is not a proposition. So it is a proposition function. So to make proposition function as proposition, we have two ways. So I hope I have made the point clear. Yes. So now, yeah. So all these are propositions. So for all x px, clearly it is false. Now there is x px, so it can be the true or false, obviously. Okay. So what is the value? Obviously it is true. I have told you just now. P2, P2 is clearly false. Why? Because 2 plus 2 is 5. That is false. Anyhow, this is a proposition. No problem. For all x not p, this is important. What do you mean by this? For all x not px means for every value of x, px should be false. Then I will say for all x not px is true. What does this mean? For every value in the domain, okay, for every value of x, for every value in domain, for every value in domain, px must be false. Must be false. This is the mean. So clearly you will say for every value in the domain, px must be false. How? P3 is true now. Okay. I have one value of x for which this equation is true. So clearly I will say this equation to be false, or this proposition to be false. Why this proposition is false? Because for all x not px means for every value in the domain p of x must be false. Okay, but I have shown you one value for which px is true. Okay, I have shown you one value in the domain for which Px is true, and that value is what? 3. I hope I have made the point clear. Yeah. So last option, see, last option. So there is this text not of Px. So what does this mean? So for uh, for for at least one value, for at least one value in domain P of x must be false for at least one value. Okay, so are you able to give me at least one value for which this is false? Clearly, yes. So you can take value of x as to be 1, or you take x to be 2, and so on. So clearly this statement is true. So I hope I have made the point clear how you will check all these kinds of things. Now please take snapshot. I will jump to the next slide. Okay, and please try to concentrate here. Domain, you have to concentrate on the domain. Okay, now in GATE exam, they can switch the question. They will say domain of x is z minus 3. If they say like this. So directly indirectly they want to say, okay, or let me say like this, z plus positive integer, and you are excluding 3. 3 is not in the domain. So now clearly this will become true. Why this will become true? Because for all x, px should be false now. So it was true only for one value, that was 3. So there is no other value for which it is coming to be true. So when I am not taking in the domain, I am not taking 3. So clearly this will become true. Okay, so you have to consider in GATE exam what domain they are saying. You have to carefully see the domain. Okay. So now for this domain, this will become true. Yes. Please take snapshot. I will jump to the next slide. I'm jumping now. So this was question number 1 we have done. Question number 2 I'm showing you. Yes. So P of x, so root of x is real. So now for all x px, there exists x px. For all x not px, there exists not px, and so on. These options are given to us. Now I have not given you the domain. Are you able to see? I have not given you the domain. So your first question should be, sir, what is the domain? I have not given you, and this is a GATE question by the way. They have not given the domain, so by default, what we will take? We will take real number as a domain. So now I want to say px root x is real. So for all x px, so is this true for every real number? That I want to say square root of every real number is a real number? No, square root of -1. -1 is a real number. Na? Square root of -1 is not real. So clearly this statement is false. There exists x px? Yes, obviously. You take 1, you take 2, you take 3, all these are real numbers. So you have to just give me at least one real number for which root r is real number. Obviously, I can give you many. Forget about one, I can give you many. So obviously it is true. Now for all x, not px. So for every x, px should be false. Obviously, this statement is again false. Why? Because for some value it is coming to be true now, like this. So now I will say like this. This is a counter example. I will say I have got a real number whose square root itself is a real number. So clearly this statement will be false because it is saying for every x, p of x should be false. I think I have you have got the point. So there exists x for which px is false. Yes, I have shown you -1. So clearly this statement is true. Yes, if anybody is having any doubt, please let me know. Otherwise, I will jump to the next slide. I think this should be crystal clear to everybody. These are very simple things.
Yes, sir.
Yeah. Okay, okay. I'm jumping to next slide now. Yes, so this is question number 3. So till now, what we are doing, we have taken only one variable, okay, like px and px. Now I am taking two variables, pxy. So now I am saying pxy, x plus y is equal to 10. This is the proposition function which is given to us. So domain we have given as integers. So now clearly I will check. Obviously this is not a proposition. This is a proposition function because it entirely depends on value of x and y. What are the value of x and y? Accordingly it will take value true or false. So obviously it is not a proposition. It is only a proposition function. Now I will apply values. I have shown you two ways. Give some values or quantify. So I am giving some values. P23. P23 means 2 plus 3 is equal to 10. Obviously it is false. 5 plus 5 is equal to 10. Obviously it is true. And so on. Okay, so I can give values and I can check it is either true or false. So clearly these all are propositions. Now this is really very important. Make some stars over it. These type of question have been asked many times in here. So let me show you how to solve them. So first first is saying for all x for all y pxy. What does this mean? For every pair of x and y, x plus y is equal to 10. That means for every pair of integers, x plus y is equal to 10. No, clearly it is false. For example, this is one pair, x and y pair, 2 and 3, and it is not coming to be 10. So clearly first statement is false. So what it is saying, for every pair of integer, for every pair of integer, for every pair of z I am writing, just to save the time. For every pair of z, it should be true. Okay, or every pair of z sum to 10, okay, or sums up to 10, sums up to 10. So clearly this is false. For every pair of integer I cannot say their sum is 10. Okay, next, there exists x, there exists y, pxy. So what does this mean? There exists x, there exists y. So you should be able to find at least one x and at least one y. So obviously what it is saying, there exists at least one pair. So you just give me one pair of integer whose sum is giving us 10. Obviously, this is the pair. And you can take many pairs, like you can take 3 and 7, okay, 7 or 3, or 2 or 8, 8 or 2, and so on. You can take many pairs. Okay. So for any pair, so let me copy it just to save the time. Let me copy it. So I will say for every pair of z, okay, for any pair, for at least one pair, or at least one pair of z sums up to 10. Clearly this statement is true. Clearly this is true. So I think you have got it now. For at least one pair of z, you just give me one pair of integers which sum up to 10. Yes, this is true. I can show you many pairs. Okay. Next is, but now complexity will come. So try to concentrate here. For all x, there exists one. And second is, there exists x for all y. So many of you will think that C and D option are same, but no, they are not same. What C is saying, for all x there exists y. So you consider them as a nested loops in case of C for all x. So that means what? I will say like this. So x can take any value for all x. There exists y. So for each and every value, there should be some y such that their sum up to 10. So you take any value of x. So that means for each every integer, you take each and every integer one by one, and for that integer you should be able to find at least one y, for which this should comes out to be true. So for every integer there exists at least one integer. For every z there exists at least one z, or we have. Okay, let me write it. We have at least one z. We have at least one z such that x plus y is equal to 10. So for every x, let me write it like this so that you get more clarity. For every x, we have at least one y, and both are integers by the way. Okay, we have at least one y such that x plus y is equal to 10. Clearly, this is true. So you take any x. So you take say x as minus 100. Immediately I will say okay. Yeah, now I will try to find any integer such that their sum up to 10. So clearly, I will say you take 110. Answer is coming to be 10. So, or in that, so I can say like this also, x plus y is equal to 10. So y is equal to 10 minus x. So x is integer, y is integer. So integer is equal to 10 minus integer. So if I do 10 minus integer, clearly I will get an integer quantity. So clearly this statement is true. No doubt at all. Are you getting it? So you subtract all the integers one by one from the 10. Finally, you will get an integer as your answer. So that's what I was thinking. So that's what this statement is saying. So for every x, we have at least one y. For every x, we have at least one y. I hope I have made the point clear. So what this statement is saying, okay, what this statement is saying, there exists x for all y. So for or you can say uh, some x exists for every y such that x plus y is equal to 10. So directly indirectly I want to say, you may be thinking that both are equivalent, but no, they are not equivalent. Try to concentrate here. Some x exists for every y such that x plus y is equal to 10. So you will first fix the x, okay, and then you will try to find that is it can I put any y and such that x plus y comes out to be 10. So I will first fix the x. And then I will try to loop all the integers. And then I want to say whether their sum is coming to be 10. I will say, okay, their sum is not coming to be 10. Now I will take some other integer. And then I will loop around all the integers. And then I will say their sum up to 10. No, clearly it is false. So I cannot find any one integer such that I can add any integer to it and I will get the sum as 10. So directly and indirectly, this is saying find some x such that I can take any integer and I can add that integer to the x and I should get sum as 10. Clearly this is impossible task. So clearly this is false. And this was clearly true. And this is false. I hope I have made the point here why this is false. Okay, so shortcut is that there exists x for all y. When there exists is outside, so you will say I have to fix x, and then after fixing x, I have to put each and every integer. Are you getting it? So like this we have to do. Okay, yes. So finally I should say like this. See, I can derive many shortcuts. Okay, but one of the basic way to solve these kind of question is that whenever I have this kind of thing, na, so you will fix x, and you will wrap around all the domain and all the values of domain, and you have to say pxy should be true. Okay, so keep on fixing x and then you wrap around values and so on. So directly indirectly I will say, see, x plus y is equal to 10 na, so I will say x is equal to 10 minus y. Okay, so since x is dependent on y, so clearly I cannot find any x for which each and every value of y this statement is coming to be true. Are you getting it? So this thing cannot be done. So directly indirectly there exists x for all y, this should be true. It will be true when x is independent of y. This is very, very important point. Independent of y. Okay? It will be true when x is independent of y. See, if x is independent of y, that means, for example, I say I have got x is equal to 10. Some equation like this. So now I can put any value of y when x is not dependent on y. So obviously this it will be true always. Are you getting it? So finally, this statement will be true only in those cases when x is independent of y. Okay. So there exists x for all y will be true only in those cases when x is independent of y. When x is dependent on y, so clearly I cannot find any x. So I cannot fix the value of x. And still I am saying that this is coming to be 10. It is impossible. I hope I have made the point clear to everybody. So now coming to the option E and F. If you see carefully, C and E are almost same, only X and Y I have swapped. Similarly, D and F are almost same, only X and Y are swapped. So obviously they will be equal because this equation is symmetric. X plus Y is equal to 10 and Y plus X is equal to 10. One and the same thing only. So so C and E option will be equivalent. D and F option will be equivalent. I will not waste time here. Okay, I will show you some other example. You will get more clarity. So for this example, I will say C and E are equivalent, D and F are equivalent. So when can I say? When can I say for all x there exists y that is equivalent to for all y there exists x? When the proposition function is symmetric. Is symmetric. Symmetric means I think you have got it. X plus y is same as y plus x. That's why. So for all x, there exists y will be same as for all y there exists x when proposition function is symmetric. Similarly, there exists x for all y, there exists x for all y that will be symmetric to that will be equivalent to there exists y for all x same when proposition function is symmetric. So they will be different when the function is not symmetric. Anyway, I will tell you all these things in the next subsequent slide only. Okay. Please take snapshot. I will jump to the next slide now. I have put everything on one slide. Please take snapshot. I'm jumping to next slide now. So next question is this. So clearly now you will get more clarity here. Pxy is x plus y square is equal to 10 and domain is integer, set of integers. So first is clearly for all x for all y. That means for every pair of x and y, Pxy should be true. Clearly this statement is false. So I can say for every pair of integer x plus y square is equal to 10. No, I can give you lots and lots of counter example. For example, x is 1, y is 2. So 2 ka square is 4, 4 plus 1, 5, 5 is not equal to 10. Clearly this statement is false. So for every pair it should be true, and so for some pair it should be true. Okay, for every pair of integers, let me write in the shortcut method. For every pair of integers, for every pair of integers, why integers? Because domain is integers. So what it is saying, for some pair of integers, for some pair I have, for example, you take x is equal to 1, y is equal to 3. So 1 and 3 square is 9, 9 plus 1 10. Obviously, I have shown you one pair. So that's game over. So this is true. So this is false. This is true. Next, for all x there exists y. So I have told you for all x. That means for each and every x there exists at least one y. For each and every x there exists at least one y. For each and every x we have at least one y. We have at least one y. Is this true or false? So for each and every x there exists at least one y. So for each, so let me write it like this. So you will keep on rotating or you will keep on supplying values from the integer set, okay, and you will add it by y square and finally you should get 10. So is it possible? So directly indirectly I want to say that y square is equal to 10 minus integer. So y is nothing but under the root 10 minus integer. So now y should come to be integer now because their domain is integer. So 10 minus integer square root is always integer. No, you can take I to be say 3. 10 minus 3 is 7. Under root 7 is not an integer quantity. So clearly this statement is false. So this is how you will prove it. So for all x there exists y. In the previous case, see this. This was true. For all x there exists y. It was coming to be true. Why it was coming to be true? Because for every x there should be y. Nah. So for every x, see this. For every x there should be some y. So directly and directly I can supply any integer quantity here and I can add y and I should get 10. So finally y is equal to 10 minus integer. I have got it. Now see this. Finally y is equal to 10 minus integer. So now I want to say this is 10 and integer. So 10 minus integer is always integer or not? Yes, it is always integer. So it was true. So but here the problem is that y square is equal to 10 minus integer I am doing and y is under the root 10 minus I. So clearly we will not get integer in every case. So obviously this is false. So for all x there exists y, this is false. Why? Because I can show you one x for which I am not able to find a y. But this is saying for each and every x there should be at least one y. So now I am able to show you one x. So what are the x? So 3. So 3 plus y square is equal to 10. So I have shown you one x for which I am not able to find a y. No doubt I am able to find y. Y is root 7, but root 7 is not integer. See the domain. So clearly it is false. Next, there exists x for all y. I have shown you the shortcut. What was the shortcut? When there exists outside, so y should be independent of x. That should be the case. But y is not independent of x here. So what I am getting y square is equal to 10 minus x. Okay, so y is dependent on x. So clearly this will be false. Clearly this will be false. Okay, because y is dependent on x. Y is dependent on x. And why I have developed that shortcut, you should be able to prove that also. There exists y for all x. That means what? I should get at least one y for which every x this proportion function is coming to be true. So I have to fix one y. I have to fix one y, and then I can rotate all the integers one by one, and then I should get the answer as that. So what is that magical number? I cannot have that magical number that I can add with each and every integer and finally sum is coming to be 10. That is not at all possible. So clearly this statement is false. Next is for all y there is a text. Now you should be careful. See this C and E option. In the previous C and E, I have told you that they are equivalent. Why? Because proposition function was symmetric. But is this symmetric? Can I switch the role of x and y? No, because other equation will become x square plus y is equal to 10. Clearly, they are not equivalent. Huh? X plus y square is equal to 10 or x square plus y is equal to 10. They are not equivalent. So clearly, they are not symmetric. When they are not symmetric, so obviously we will not get the same answer. So let me show you here. For all y, there exists x. So what does this mean? For each and every value of y, there should be some x such that it is true. So for each and every value of y, there should be some x. So what I will say, I will keep on rotating here. So x plus y square is equal to 10. So I will say, I will keep on rotating integer quantity here. So first of all, tell me y is an integer. So integer square will be obviously integer. And now I want to say x plus some integer. Why? Why I am saying it as integer? Because integer square is nothing but integer only. So y is integer, so y square is also integer. Na? See, its reverse is not true. Its converse is not true. So, I am saying y is integer. Y is integer implies y square is integer. But its converse is not true. Y square is integer means y is integer. That is not true. I think you have got it. This is really very simple scenario. So if square is integer, that means y is also integer. That is not the case. So I hope I have made the point clear to everybody. For example, say 3 is integer. So what do you mean by this? Root 3 is integer? No, then it is not true. Yes. So main thing is that y square. So y was integer. So obviously y square is also integer because integer square is also integer. So x plus integer is coming to be 10. So what is x? X is 10 minus integer. So clearly this is integer. This is also integer. So 10 minus integer is obviously an integer quantity. So this statement is coming to be. So for every y, there exists x. So clearly, C was coming to be false and E is coming to be true. This is false now, and this is true. So obviously, how they are equivalent? I hope I have made the point clear to everybody. So for all y, there exists x means for each and every y, there should be some x. For each and every y, try to consider it. For each and every y, there should be some x. Yes, I have got it. For each and every y, there will be some x. You just give me any integer. I will take its square. For example, you take 2. 2 square is 10, 4. So x plus 4 is equal to 10. So clearly x is coming to be 6. Then this is integer quantity. You take any integer, it hardly matters. Yes. So next is there exists x for all y. Same scenario. There exists is outside for all is inside. So x should be independent of y, but it is not the case. X is coming to be 10 minus y square. So x is dependent on y. So clearly it comes out to be false. So I want to say that there exists x. So there should be some x. There should be some magical number x. And for each and every y, this proposition should be true. So I am not able to find that number. I hope I have made the point clear to everybody. If you still have any doubt, I will say like this. So you should give me one number. You just give me just one number, and I can add with square of every integer, and its sum should come to be 10. Here it is impossible. I cannot give you one such number. Clearly, this statement is false. Okay. Please take snapshot or something. I will jump to the next slide now. So now see, till now were doing two variable. Now I am jumping to three variable x, y, z. Question is x plus y plus z is equal to 10. Domain is again integer quantity. For all x, for all y, for all z. So that means for every triplet px, y, z, obviously this is false. So how it is false, you just give me counter example. I will take x as 1, y as 2, z as 1. So answer should be 10 now, but here answer is coming to be 4. So clearly I have shown you one triplet for of integer, one triplet of integer for which this statement is coming to be false, so obviously it will be false. So here what I want to say, you just give me at least one triplet for which this is true. So I can give you, forget about one, I can give you many triplets. So for example, you take x to be 1, y to be 4, and z to be 5. So what we will get, 5 plus 4 plus 1, 10. So clearly the statement is true. So these are very simple. Anyhow, I should not waste time here. These are very simple. This is false and this is true. What about this scenario? This is saying what? For every, see now try to concentrate. For every pair of x and y, for every pair of x and y, there should be some integer quantity such that their sum gives us 10. So every pair of integers. So now I will say x plus y plus z is equal to 10. So you rotate both of them. You rotate both of them, and I want to show you. So you rotate one of both of them, and you should be able to find one number for each rotation such that you sum up to 10. Obviously, this is true now. So you take x as 2, you take y as say 10, and so what should be the z? 10 plus 2 is 12. So z must be minus 2. So for this pair, I have shown you minus 2 is the answer, and this is summing up to 10. Let us take another pair, 3 plus 5. So what should be the, so I have taken one more pair, 5 plus 3 is 8. So I will add 2 here, and finally I will get 10. So what I am going to say is, for every pair of x and y, there should be some z such that their sum up to 10. For every pair of x and y, for every pair of integers, for every pair of z, let me write it. For every pair of z, there exists z such that actually na, you may get confused here. For every pair of, okay, x and y, x comma y, for every pair x comma y, they are integer by default. Now for every pair x comma y, there exists z such that x plus y plus z is equal to 10. So I am able to show you these things. So clearly this statement is true. C is true. Next, for all
Sir,
x, yeah,
why is one false, sir?
y one false for every triplet. So
Yeah.
for every triplet, sum up to 10. So I have shown you one triplet, 1, 2, and 1. Are you getting
Okay.
it?
Yes, I'm getting it. Like as we have got the C option, 2 plus 10 plus
Hmm.
minus 2.
Hmm.
So here also we can think the similar way, no, sir? Because
No,
Z is to be fixed here. Any
yeah.
Z. Huh.
So we should be able to find at least one z for every pair.
Z is fixed. Z is always minus 2. So how can we
Hmm.
find one more pair of X and Y?
No, you keep on rotating x and y. For every pair of integers, I am using the word. For every pair of x and y. So that means for every pair of integers, you should be able to find one. So I have shown you one more pair, 3 and 5. For this pair, I have shown you 2. Let me show you another pair, 6 and 9. So 6 plus 9 is 15. So minus 5 is the integer which will give us answer to be 10. So for every pair of integers, you should be able to find one integer such that their sum will give us answer 10. If you still have doubt, please let me know. I will clear that also.
This I understood, sir. First one only, sir. I am not able to.
First one is saying for all x, for all y, for all z. So what does this mean? See, what is this? For all x, for all y. So every pair. So here also for every triplet. Nah? So what does this mean? So you take, see, actually this means what? Domain is integers. Nah? So I'm taking, say, this is the integer set. This is integer set. This is integer set. So this is x, this is y, this is z. So now I want to say you can pick any number here from here any number from here, any number from here, and they should sum up to 10. This is clearly meaningless thing. Clearly, this is false. Okay. So you take any x, any y, and any z, and still
Okay.
sum should be 10. Clearly, this is false. Not at all possible.
Okay, sir.
Okay. So what this is saying? This is saying you just find one pair or one triplet. So I have found they are saying at least one triplet should be there. So I can find many triplets. For example, say x is I have told you na, say x is 1, y is say 4, and z is say 5. So this is one triplet which I have shown you, which is summing
Right.
up to 10. So this is true. And this is saying for every triplet, this is clearly false. So you can find lots and lots of triplets which are not coming, their sum is not coming to be 10. Okay, so D option. For all
All
x,
right.
there is z for all y. Yes. D option is for all x, there exists z for all y. So I have told you, there exists is outside, for all is inside. So z should be independent of y. Only in that case it will be true. And clearly, I will say z is equal to what? 10 minus x minus y. So z is dependent on y. So clearly, it comes out to be false. So D option is false. Now, obviously, E option is also false. Why? Because there is this Z is outside. For all x, for all y are inside. So Z should be independent of both x and y. Obviously, here Z is dependent on both x and y. And I am saying Z should be independent of both x and y. So clearly, this statement is also false. This is the shortcut. Okay. Yes. So what this is saying? There exists x, there exists y for all z. So I want to say you just give me at least one pair of integers such that for that set of integers I should be able to find every z to be true. Okay, for all z. Now for all z means, see this. If you are not able to follow, see this. There exists there exists y for all, where I have shown you. Yeah, there exists x for all y. So what I was saying here, some x exists for every y. There should be some x for every y. Same is the scenario here. So there should be at least one pair of x and y for which when I put every z, their sum give us 10 value. Clearly this statement is false. It is meaningless thing. So you just give me one pair of integers. For that pair of integer, okay, I can add all the integers one by one and they should give us answer 10. Clearly this is meaningless thing. Can you give me one such pair? Can you give me two magical numbers such that for these two numbers when I add any integer it should give us 10? It is not at all possible. Clearly this statement is false. I hope I have made the point clear. And what this is saying, this is exactly opposite of it. What it is saying, for every z, that means for every z, there should be at least one pair of x and y such that pxyz is true. So what I am saying is now just reverse of it. For every integer. So one by one you pick the integer and then after picking one integer and you add, so for that integer you should be able to find one pair of integers which will give us sum to be 10. For example, you take any integer, say 5. Now I will tell you, I should be able to find at least one pair of integer for this 5 which will give us answer to be 10. Clearly, I can give you one pair, 2 and 3. It is giving us to be some 10. You take any other integer, say minus 15. So now I should be able to give you one pair of integer which will give us sum to be 10. So clearly I will take 30 and 30. I am giving I am getting the answer. So clearly this statement is true. Yes, if anybody is having any doubt, please let me know.
So can E be equal to C
Where E and C?
in the same question, sir?
Uh,
E option
okay,
E and option C, sir.
okay. E and C.
Yes, sir.
E and C, yeah. they no. Actually, they are not equivalent. Okay, because see this. Yes, for all x there exists y. That is not same as there exists y for all x. They are not equivalent. So what this is saying, for every x there exists at least one y, and what it is saying, there exists y for every x. Both are different. Please try to focus here. See this. See this. Uh, for all x there exists y, and there exists x for all y. Okay. I have not shown this. Yeah. C and F option. C and F. C and F. Yeah, your doubt is nice and logical. Yes, I think I have not told you this thing. See here, for all x there exists y, and there exists y for all x. They are not equivalent. What it is saying, for every x there should be some y. So you will keep. So for example, see this. For all x, say same. There exists y. X plus y is equal to 10. And what this is saying, there exists y for all x. X plus y is equal to 10. What this is saying, for every x, there should be at least such that their sum gives us 10. For every x, there should be some y. Yes, for every x, there is some y. But what it is saying, there exists y for every x. Clearly, the statement is false. So, what I am saying is, so you should be able to find one y, and you should be able to rotate all the integers, and they should sum up to 10. This is not at all possible. So this is false and this is true. So clearly, for all x, there exists y, and there exists y for all x. They are not at all equivalent. You cannot swap them. Okay?
So it means the order matters here, sir.
100%. 100% order matters. See, I think you are getting confused from
No, sir,
here.
I understood it, sir, now. Yes, sir.
Okay, okay.
It's clear, sir. It's clear, sir.
Okay, please take snapshot. I will jump to the next slide now.
Sir, can you explain the option D and how to derive the equation from that?
Option D.
Yes, sir.
If you, I was just saying there exists is outside and for all is inside. I have told you shortcut that whenever there exists is outside and for all is inside, so z should be independent of y. From this equation, z should be independent of y, but when I found the value of z, it is dependent on y. So clearly this will be false.
Okay, sir.
So this is a shortcut which I have deduced. You will not find this in your any textbook and all. I have just made this shortcut. So see, same is the case here. There exists y for all x. X plus y is equal to 10. Immediately you will say, sir, this is false. Why this is false? If you are able to follow this long method, this is very good. If you are not able to follow this long method, shortcut is ready for you. You will say, sir, try to find y in terms of x. I will say like this. So now y is dependent on x. Clearly, I will say it is false. So y should be independent of x. Only then this will be true. Otherwise, it will not be true. That is the shortcut. Okay. Let me jump to the next slide now. Yes, please take snapshot. Okay. Yes. So in predicate logic, we have three types of questions. First is true false type of questions, which I have already told you, which is true, which is false. There are a hell lot of questions which have been asked in GATE exam like this. So true false questions we have done. Next is predicate properties. This is really very, very important. Almost every year, one question has come from this topic, predicate properties. And the last will be translations in predicate logic. Anyway, my aim is to complete, in today's class, my aim is to complete all these predicate properties. And in the next class, we will see these translations. Okay. Yes. So let me show you the predicate properties. I'm jumping to next slide now. So three type of questions are possible in predicate logic. Okay. And by the way, predicate logic is more important than your propositional logic. Propositional logic, which we have completed. Okay. It was more lengthier. It was more, you can say, huge. But questions are coming less. From predicate logic, questions are coming more. Okay. So in logic, we have two topics now. propositional logic, and second is predicate logic. So propositional logic is 70% of the complete logic, and predicate logic is only 30% of the logic. But questions, 70% of the questions are coming from here, and only 30% questions are coming from here. So predicate logic is really very, very important. So true false question I have explained you. Lots of questions I have been asking GATE from this topic. Next is predicate properties. I am telling you this thing now. Please take snapshot. I am jumping to next slide now. Okay. So these type of questions will come. Properties means like this. For all x px implies there exists x px. Is it true or false? So directly and indirectly I want to say, when for all x px is true, does this guarantee that there exists x px will be true? This is the question. So directly and indirectly I want to say, from the domain, if in the domain for every value of x, px is true, so obviously this means that for some value it is true. So obviously this statement is true. Now of course the domain should not be empty. If domain is empty, then there is some exception. I'm not going into details of all these things. You just have to remember this is true. Domain is not empty. Domain not equal to 5. Clearly domain is 5 means it is meaningless thing. So obviously they will not ask such exceptional questions and all. Domain should not be empty. You should remember this thing. So for all x px implies there is x px. This is 100% true. Okay, so I hope I have made the point clear to everybody. So whenever for all x px is true, there is x px will be definitely true. Now, for all x means what? For every element it is true. There is x means what? There should be some element for which it is true. So clearly this implies this is true. Okay, so P implies Q. See, when can I say P implies Q is true? When P is true, Q is false. This is not possible. For example, if P is true and Q is false, if I am able to prove this thing, then clearly P implies Q will be false in that case. So when can I say P implies Q is true? True means what? Always true. When can I say P implies Q is always true? Always true, or you can say simply true. True or always true. When it is true or always true? When P implies Q is true or always true? When P is true and Q is false, that is not possible. You keep on thinking, and if you are able to conclude that it is not possible, then I will say P implies Q is true. Are you getting it? True, saying true, or always true, one and the same thing. So P implies Q will be true, or it will be always true when P is true and Q is false is not possible. So now see this. This is true, this is false. It is never possible. For all x px is true, that means for every element it is true. So obviously we conclude that for some value it is always true. So I think you have got it. So this is not possible. So it is true. What does this mean? For all x, for all y pxy is equivalent to, this is equivalent symbol or biconditional. Is it equivalent to for all y for all x pxy? Clearly. What this is saying? For every pair of x and y. Same is scenario here for every pair of x and y. So this is also true. There exists x, there exists y, pxy, there exists y, there exists x, pxy. So what does this say? For any pair, or there should be at least one pair of x and y for which pxy is true. Same is the scenario here. So clearly this is true. Okay. And I have told you in the previous slide itself, one student has asked this doubt. For all x there exists y, there exists y for all x. They are not equivalent. So let me write it here itself. So property number 5, for all x there exists y, pxy, that is not equivalent to saying as there exists y for all x, px. They are not equivalent. Okay, and what this is saying, there exists x for all y pxy, this implies this. So equivalent means what? See, P implies Q and Q implies P. Then our conclusion is that na P is double implication to Q. I have told you many times. If you are not able to remember, please watch my previous lecture. I have told you many times. P implies Q and Q implies P. When both are true, then I can say P is double implication to Q or P is equivalent to Q. So now I have told you that for all x there exists y is not equivalent to there exists y for all x. This is not equivalent, this is true. Okay, but this is also true. There exists x for all y pxy. This implies this. So I indirectly I want to say when there exists x for all y pxy is true, so this is also true. So indirectly I want to say that this is more restricted and this is less restricted. Why this is more restricted? Because it is saying, see, there is outside for all is inside. So x should be independent of y. This is saying like this. But this is not saying that x should be independent of y. This is more strict. Nah? I have told you, see this. If you are not able to remember, see this. I have just told you. For all x, there exists y. X plus y is equal to 10. This was coming to be true. Because for every x, there should be some y. And what it is saying, there should be some y for each and every x. So clearly it was false. Okay, so my aim was here. So y should be independent of x. Okay, but y is dependent on x. That's why it is false. Okay, so indirectly I want to say when there exists y for all x is true, then in that case for all x there exists y must be true. I cannot give you any case where there exists y for all x is true, but this is false. This is never possible. You can check it out from previous examples also. So that's why I'm saying that there exists x for all y pxy. When this is true, then for all y there exists x pxy. This must be true. It cannot be false. So indirectly I want to say you when this is true, okay, when this is true and this is false, it is not possible. You cannot give me any such case. I'm not going into formal proof and all. You just have to remember this thing. So you can remember like this. There exists outside is more strict than there exists inside. Why there exists x outside is more strict? Because it will say that x should be independent of y. But here there is no such case that x should be independent of y and all. Okay, I hope I have made the point clear. These are the four basic properties, and from these four properties, I will make a very beautiful diagram which will solve many questions in GATE exam. So let me show you that diagram in the next slide. Please take snapshot.
Sir, one doubt. So in all these five properties, we are assuming the left side to be true, right? And then we are predicting what could be the right hand side.
Yeah, 100%, 100%. Very good.
Okay.
Yes.
So if we don't assume it to be true, then the results could change, right? Results might change.
If we take this as false, then clearly see this. In case of P implies Q, when P is false, it hardly matters to me. Q can be either true or false. P implies Q will be always true.
Yes. Okay. Okay. Yeah. Yes.
Okay. But the problem is this now when P is true and Q is false, only in that case P implies Q comes to be false. Otherwise, it is always true. Huh?
Yes.
So when we assume this to be false, then I can say it is either true or false. It hardly matters. It will be always true. So I want to prove that this entire thing is true. So I will say this is your P and this is your Q. So when can I say P implies Q to be false? When this is true and this is false. Okay, but I cannot prove this is true and this is false in any of the case. Hence, I will say P this is true. This is always true. Okay. Yes. Anyway, please, I will show you when I will jump to the more questions. You will get more clarity. Okay. We will dig deep into it. No need to worry.
Okay. Okay.
Okay. So let me jump to the next slide now. Yes. So from these properties, I will show you very beautiful diagram. I am jumping now. So this is an octagon. I think you can check it out. These are the 8 sides. This is an octagon, and this octagon will solve many gate questions. And directly questions have been asked like this. This implies this is true or not. This is equivalent or not. This and this are equivalent or not. This implies this. This has been asked many times because this is difficult to remember. This has been asked many times in gate. Many times. Yes. Yeah. So and clearly, for all y there exists x p x y. implies there exists x for all y pxy, this is false, because I can make this as true and this is false. This is clearly false. And anyway, if this is also true and this is also true, so obviously this should be equivalent. When I am saying that equivalent is not true, this is true, so obviously this should be false. If this is also true, then equivalent should be true. I hope I have made the point clear. So converse of this is not true. This is false. Okay, anyhow, let me explain you all these things from the octagon itself. So what this octagon is saying, see this, for all x for all y, that is equivalent to for all y for all x. I have told you. Okay. So that's why I have made this double implication, equivalence. Okay, and here downside, I have made there exists y, there exists x, there exists x, there exists y. See, these are also equivalent. These are also equivalent. That's why I have drawn it here. So now I think you will be easily able to see when for every pair of x and y, pxy is true. So obviously from that I can conclude that there exists x for all y will be true. Now there exists x for all y implies for all y there exists x. See this? There exists x for all y implies for all y there exists x. Now from this I can imply this, because it is saying only one pair. You should give me only one pair, and this is saying for all. Na? So obviously this is more complex and this is easy. So from here I can get here. These are all already equal. Now see this. For all y for all x, from here I can reach here. Why? Because it is more strict. It is saying for every pair. Okay, but it is saying there exists y for all x. Now from here I can come here. Why? Because there exists outside, so it is more strict. When there exists become inside, it will become less strict. From here I can come here. So this is an octagon. Okay, and how many questions it will solve? Let me show you. How many? See, what are the eight? Now 1, 2, 3, 4, 5, 6, 7, 8. 8. So eight sides, or you can say 8 vertices are there. So from these 8, they can give you any two, and they will say which implies which. For example, they can give this and this. They will say which imply which. Okay, so from 8 you can take any pair. From these 8 you can take any pair. So or you can pick any two. So 8C2. Anyway, I will tell you all these things in combinatorics. If you are able to follow, it's really good. Otherwise, just leave it. I am just showing you how many questions you can solve in gate from this simple octagon. So 8C2. 8C2 means from 8 you can pick 2. Now, after picking 2, I will multiply it with 2 also. Why? Because they can switch them. For example, they will say for all y, for all x implies for all x there is y. First question, second question will be flipping them. After flipping them, they will say for all x there exists y implies for all y for all x. So 2 question from each pair. So 8C2, 8 into 7 by 2 into 2, 7 8 the 56. Total 56 questions can be made from this octagon itself. Okay. So now this implies this is true or not. Obviously you will say, sir, this is true. Why? Because there is a path from here to here. From here I can come here, from here I can come here. So obviously this implies this is true. But this is not true. Nah? For all y there is text implies for all y for all. This is not true. Why? From here I cannot reach here. If you think, sir, I will come from here to here. Now this is both directions, so you can go here also, here also. So obviously you will go here. But from here, how you will go here? This is one way. So there is no path from here to here. So obviously this implies this is false, but this implies this is true. So like this you will answer in gate. This is very beautiful shortcut. Okay, and you can solve 56 questions from here. Let me show you some examples so that you get more clarity. Let me show you that. I'm jumping to next slide. See this. For all x for all y pxy implies there is x for all y pxy. For all x for all y. Where is it? For all x for all y. There is x for all y. There is x for all y. So from here to here I have a path. Directly I will say this is true. For all y there is x. For all y there exists x. Where is yeah. For all y there exists x is here. And there is x, there exists y. There exists x, there exists y. Yes, we have a path like this. So this is also true. For all x, for all y, there exists y for all x. For all x, for all y, there exists y for all x. There exists y for all x. Yes, from here I can come here, from here I can come here, so we have a path. So clearly this is for all y there exists x, for all x there exists y. For all y there exists x, and for all x there exists y. For all x there exists y. So from here to here I want to jump. So how? Here from here I can come here, but from here I cannot come here. So obviously this will be false. Okay, so I hope I have made the point clear to everybody. So this implies this is false. Clearly this is false. Similarly, opposite of it is also false, huh? Because there is no path from here to here also. From here I can come here, from here I can come here, but from here how I will go here? It is not possible. So for all x there is this y. So let me write it here itself. So, so question number 5. And I will just flip this arrow. Like this I will say. For all x there exists y2, for all y there exists x. For all x there exists y, sorry, yeah. For all x there exists y, to for all y there exists x. There is no path. There is no path, so it is. I hope I have made the point clear. So I have shown you 5 such questions, and how many questions are possible? 56 questions are possible. There are high chances that they will ask you this kind of question. You just draw it 2 to 3 times, at least 2 to 3 times you draw, you will be able to follow it. So as soon as you find such kind of question in GATE, you immediately make this octagon and try to answer it. You will immediately get the answer. That is the beauty of this octagon. Okay, and anyhow, you do not need to buy heart. You just have to see this. This is more strict. This is less strict. So clearly, from here I can go here. Now there is this taxes outside, so it is more strict, and there is this taxes inside. This is less strict. From here to here I can come. Now this is clearly more strict, and this is just saying only one pair. So from here to here I am coming, and so on. So you can make this octagon right. So now for all x, for all y. So like this I have done. So now for all y, for all x. So from here I have done like. Okay, please take snapshot. I will jump to the next slide. I will not waste time here. Let me jump to the next slide. Okay, so I hope you have taken the snapshot. Next, take snapshot of this slide also. Yes, I'm jumping to the next slide now. So now these are very, very important properties. This type of questions have been asked in GATE many times. So they can give you the mathematical formula also, or they will say like this. They will say for all is distributive over n. This is true or false. For all is distributive over n. Is it true or false? They can say like this also. So no need to by heart this statement. You will simply convert it into like this. I think you already know from the Boolean algebra. I have told you many times. When can I say dot is distributive over plus? So I say like this. Na, A dot B plus C. Dot is distributive over plus means what? A dot B plus A dot C. Like this I told you many times. So same scenario here. For all is distributive over and means what? For all is outside and is inside. So I will say for all x px and for all x qx. So I have distributed this for all over and like this. Is this true or false? So that means are these two equivalent? If this and this are equivalent, I will immediately say okay. For all is distributive over n. So now how will you prove that this is distributive? So let me show you. First of all, you should know how to expand this kind of thing. You will say, you will consider this as a black box. Okay? And for all is there. So I will write like this. First time black box and second time black box and third time black box and fourth time black box and so on. Okay, why I am writing and? Because for all, see this, for all always and. See this meaning of quantifier. For all was when, for all was true when, and I was doing that. So that's why I have done and here. Yes, so that's why I have done and here. Now, what will come inside the black box? So I will say like this. So they are now combined now. So x, according to the value of the domain, according to the domain, we will get the value of x because these are proposition function. Px and qx, they are the proposition function. So I can take value of value as x1, x2, x3, and so on. So I will say like this: p of x1 and q of x1. You will have to write like this only. X1 and x1 same. Why? Because I am expanding for all. So this was a black box. So when I open the black box, so you have to put the same values here. Similarly, I will take px2 and qx2. Similarly, I will say px3 and qx3. It's actually it is becoming a bit difficult to see. So let me do a shortcut. Okay, so px1 I will write it as p1. It's my notation just to save the time. Okay, so and to keep the things neat and clean, I am writing like this. Okay, anyhow, it's first question, so let me do it properly. No problem. I will do it properly. From the next question, I will apply the shortcut. Okay, so let me write it properly. P of x3 and q of x3. Similarly, p of x4 and q of x4 and so on. How you will expand it? For all x px, it is very simple. P of x1, okay, and p of x2 and p of x3 dot 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 dot. How you will expand it? You will expand it q of x1 and q of x2 and q of x3 dot 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 dot. Now in between, see this was the and, so obviously I have to apply and here. Let me write it in a different color so that you get more clarity. Because of this and, I will apply here and. So directly everywhere it is and. Px1 and px2 and px3 and so on. Then and, then qx1, qx2, qx3 and so on. So here also see, you take like this. And is commutative as well as associative. So you take it like this. So px1 and qx2, px1 and px2 and px3 and px4 and so on, qx1 and qx2 and qx3, qx4 and so on. So finally, both are equivalent. I think you can check it out yourself. I hope I have made the point clear to everybody. So now in the GATE exam, this much long proof you may not be able to remember. So let me show you a very simple idea that in GATE exam, how you will check it out, all these kinds of things. So I will, first of all, I will use this shortcut. Px1 will be same as P1 just to save the time. So you just expand it two times only, two times. So I will say P1 and Q1 and P2 and Q2 like this. Now is this equivalent to saying as expand this two times? P1 and P2. Expand this two times. Q1 and Q2. And there is and in between, so we will apply and. So clearly you will say these two are equivalent. If you still have doubt, you can convert it into Boolean algebra. I will say P1 dot Q1 dot P2 dot Q2. And is this equivalent to P1 dot P2 dot Q1 dot Q2? Clearly, these two are equivalent. So hence, I will say for all is distributive over and this statement is 100% true. I hope I have made the point clear. So in GATE, this is the actual proof just for the theory point of view. To clear your doubts and all, I have done this proof. But it is not required for GATE. This is for GATE. In GATE exam, no need to by heart all these things. This is really very tough because I will, or you will say that this is only one statement, but there are many such statements. How you will by heart all of them? You cannot by heart them. So better is just leave them. In GATE exam, try to follow this approach. You will immediately get the answer. This is really very simple. P1 and P2, P1 and Q1, and P2 and Q2. So you just remember this thing, how to expand them. That's Okay, finally you will get the answer. Please take snapshot. I will jump to the next slide. And what is P1 Q1? I think you have got it. Px1 I have changed to P1 just to save the time. It's my notation. I have just changed it. That's it. Okay, and x can take the value x1, x2, x3, x4, and so on. It will come from its domain. So I have not given the domain. I have just showing you all these things. That's it. Yes. Please take snapshot. I am jumping to next slide now. Okay. Next is there exists text px or qx is equivalent to there exists text px or there exists qx. This is the expanded form. In GATE exam, they can ask directly this, or they will say like this. But they will say there exists is distributive over all. Is distributive over all. Is it true or false? Like this, they can ask. Is this true or false? So you will not by heart, you will change it to this. So there is text px or qx that is equivalent to there is text px or there is text qx. So just now I have told you the idea for GATE exam. I will apply that idea only just to save the time. So I will simply say expand it two times, P1 or Q1. I think you have got it. Now there is text is outside, so you will apply same thing, P1 or Q1. Or why this or is coming? Why this or is coming? Because there exists coordinate. And next time I will say P1, P2 or Q2. Okay, so this or is because of there exists. I think you have got it. This is very simple scenario. Now you will expand it two times, P1 or P2. This is or, so you will apply or, and you will say Q1 or Q2. If you have doubts or why you are writing or, see this, see this. So there exists text px, so I have to write or in between them, na? Because there exists text px is true means what? For at least one value it should be true. So that means or, sense of or is coming. For all, sense of and is coming. Okay. So now, yes. So clearly, I think you can see yourself also. So if you have still doubt, change it into Boolean algebra. P1 plus Q1 plus P2 plus Q2. So is this equivalent to P1 plus P2 plus Q1 plus Q2? Clearly, it is equivalent. So this statement is coming to be true. Please take snapshot. I will jump to the next slide now. Okay, now I'm jumping. So next is this. There exists text px and qx that is equal to there exists px and there exists qx. So clearly what they want to say, there exists is distributive over n. I want to prove this is true or false. So really very simple scenario. I have told you, just expand it, you will get the idea. No need to by heart. Expand it, you will get the idea. So there is this text is outside. So and is inside now. So you just know how to expand it. P1 and Q1. Because of there is, you will apply or P2 and Q2. Like this. Now, is this equivalent to saying as there is text Px, P1 or P2 and Q1 or Q2? So, if you clearly they are not equivalent, but still if you are not able to follow, convert them into Boolean algebra. P1 Q1, P2 Q2. Is this equivalent to saying as P1 plus P2 dot Q1 plus Q2? Clearly they are not equivalent. Still you have doubt, expand it. P1 Q1 plus में P1 Q2 plus में P2 Q1 plus में P2 Q2. Who will say they are equivalent? Clearly they are not equivalent. Yes. So finally, what I will say, this statement is clearly false. Statement is false. Yes. Please take snapshot. I will jump to the next slide now. There exists a distributive over n. False. Clearly you will say it is false. Okay, I'm jumping to next slide now. So now this is really important. How you will check one way. Okay, or okay, let me come back to it just after a while. Let me show you this first. Okay, so this was the third property I have told you. There is a distributive over and false. So now let me show you for all is distributive over all. Okay, let me change the slide number also. Otherwise, some of you may get confused here. So yeah, yes. So this is the fourth slide. What it is saying? What it is saying? For all x, px or qx is equal to for all x px or for all x qx. So clearly, they want to say for all is distributive over all. I want to say this thing. I will expand it and get the answer. P1 or Q1. Because of for all, I will apply and P2 or Q2. If you are able to expand, that means 99% of the question is over. 99% question is over. If you are able to expand it properly, that's okay. Now I want to say this thing for all x px. So P1 and P2 or Q1 and clearly I am able to see that they are not equivalent, but still you have doubt, convert it into Boolean algebra. P1 plus Q1 dot P2 plus Q2. Is this equal to saying as P1 P2 plus make Q1 Q2? No. Who will say they are equivalent? Clearly they are not equivalent. If you still have doubt, you can expand yourself. I am not going into details and all. These are not equivalent. So finally, this statement is false. Please take snapshot. Now I will jump to the next slide. So these are the simple question, which is distributive, which is not distributive, and so on. Okay. Yes. So summary, I can say for all is distributive over and there exists distributive over all. For obvious reasons, you can think, for all is just like so that's why it will be distributive over and there exists just like or, so obviously it will be distributive over all. Okay, and for all distributive over or no, there exists distributive over and no. This is the summary till now. Please take snapshot. I will jump to the next slide now. And jumping now. So now see this. These are the one-way theorems they can ask. One-way type of thing like there exists x px and qx implies there exists x px and there exists x qx, like this. They will ask me. So how you will prove that they are this is true or not true? So I have told you. You consider this as p and this as q. Try to make this as true and this as false. If you are able to make it, you will immediately say this formula is not valid. Otherwise, you will say it is valid. They can ask like this also, which of the following formula is valid or which of the following is tautology, and so on. They can ask valid or tautology, one and the same thing. I have told you many times. See my previous lectures. Valid or tautology, one and the same thing. Yes. So they can ask like this. So I should be able to say that this is true and this is false. If I am not able to make this as true and this is false, I will say okay, this is a tautology. Otherwise, I will say this formula is false. Directly and directly, I will say this is not always true. This is not always true. Yes. So let me show you this. So see this. If you want to make it as true, so let me expand it first. So what I will do, P1 and Q1 or P2 and Q2. This implies what? P1 or P2 dot Q1 or Q2, like this. So now in order to make this as true and this as false, what should be done? Okay, what should be done? Okay, yeah, so I think I should apply and here. I have mixed both logic and Boolean algebra. I should not mix them and or like this. Yes. So what should be done? So in order to make this as false, so you should try to minimize the things. Minimize the things means if I want to make this as false, so clearly you can take any one of them to be false. So you take just one of them as false. Obviously, you take both of them as false also, but it will not help you out. So better is to take minimum, to do minimum work. Minimum. These are very beautiful shortcuts which I am telling you. Okay, try to focus here. Minimum work should be done. So you take, you make this as false, and you make this as true. So first of all, you should think like this, which is more easy, making this as true or making this as false, which is more easy. So you will say to make this as true, there are three possibilities because there is or here. You can take this as true, this as false. You take this as true, this as false, or you take both as true. So there are three possibilities here. Similarly, here also for to make them as false, there are three possibilities. You make this as false, this as true. Make this as false, this as true, or both as false. So obviously there is no trade-off between them. So you can start from wherever way you want. Okay, and we have to do minimum work. Minimum work. So what is the minimum work? So I will first of all I will assume that you make this as false and you try to make this as true. So finally what you will get false and true as false only. So in order to make this as false, clearly you have to take both of them as false. Otherwise you cannot make it as false because there is or here. So though there is only one possibility to make this as false, you have to take both of them as false. Now as soon as you make P1 and P2 both as false, immediately you will come here and you will say P1 is false, P2 is also false. As soon as you will make them as false, you will say this is also false, this is also false, false or false is false. So directly, indirectly, in order to make it as false, I have to take this as false. I cannot take it as true. Finally, I will say my attempt to make this as false and this as true has been failed. Clearly, this formula is a valid formula. Okay, and you can think like this also. So you want to make this as false and this as true, na? So make in order to make why I have come here, why I have make this as false first and not make this as true, because to make this as true I have to consider many possibilities. Q1 true, Q2 false, Q2 true, Q1 false, both are true. And here to make it as false only one possibility, you have to take both as false. So that's why I have used the word minimum one. You have to do minimum one. Now same scenario, if I make this as false, this as true, so obviously to make this as false you have to take both of them as false. When you take both of them as false, this will be false, this will be false, and clearly finally you will get false. So you can no longer make it as true. This is the simplest way to explain the things. So clearly this is a valid formula. If anybody is having any doubt, please let me know. Otherwise, I will jump to the next slide.
Clear, sir.
Okay, then. It's really good if you are able to follow. Let me jump to the next slide now. So this is true or not, I have to see now. Okay. By the way, let me tell you one thing. For all is not distributive over and, na? And I have told you this is true. See this. For all, yeah, there exists. There exists is distributive over and, that was false. I have told you. So if I take this as P, this as P, and this is Q, I am saying P double implication to Q is false. And I am also saying that P implies Q is true. P implies Q is true, na? See this. This was P, na? This was P, na? So P implies Q is coming to be true. P implies Q is coming to be true. And I am saying this is false. So clearly Q implies P must be false. If Q implies P was also true, then obviously P double implication to Q will be true. Huh? But I have told you P double implication to Q is false. P implies Q is true. So obviously Q implies P must be false. This is the simplest proof what I can give you for this. So it will be false. But let me show you this thing, because in GATE exam you cannot remember all this kind of thing. Na? In GATE exam you cannot think, okay, double implication was true and this was true, that's why it is false. I have linked the thing so that you are feeling that it is easy. But in GATE exam you cannot apply this shortcut, because to apply this shortcut you have to remember two things. First thing is this is true. How you will remember this is true? It's a really very beautiful, difficult kind of thing, because you at the end of the logic I will give you lots and lots of formulas. How you will remember this is true? And this thing I think you can remember. There is this is not distributive overhead, but this thing you cannot remember. Okay, so let me show you from the scratch how you will prove it. From scratch how you will prove it. You do not know nothing. You don't you know nothing about it. Let me show you how you will prove it. So same scenario. I will try to make this as true and this is false. So okay, so first let us expand it. Only then I can show you. No? So there is this px and there is this qx. So there is this px means p1 or p2 and q1 or q2, implies there is this x px and qx. So p1 and q1 or p2 and q2. Okay, why we have applied or? Because of their existence. So now try to prove this as true and this as false. Now see this. Which is easy? What do you think which is easy? To make this as false because of or, there are three possibilities. What are the three possibilities? Either you take uh, both as false, or sorry, for or na, and we have to take it as false. So only one possibility. Yes, only one possibility that both should be false. Because false or false is false. If even one of them is true, then answer is true. Only one possibility is there. So obviously it will help us. Similarly here also this is true. So to make this as true, only one possibility that both should be true. So I can take any way, whatever way we want. You can start from here or you can start from here. So let me start from here. I want to make it as false. So to make it as false, I have to take this as false and this as false. In order to make this as false, so there are three possibilities again to make this as false. Either you take any one of them as false or you take both of them as false. And I have told you, you have to do minimum work. Minimum work means you take any one of them to be false and any one of them to be true. So let me take this as false and this as true. P1 is false, Q1 is true. Same scenario here. To make it as false, let me take P2 as false, Q2 as true. Immediately when you have assigned these values, so let me assign the values here itself. P1 I am taking as false. P2 I am taking as false. False or false is false. So I will not put values here. I will say false and something will be false only. So I am not able to make it as false. But you will not stop here itself. You have to consider other possibilities also. So first way I have taken this as false, this as true, this is false, this is true. Let me swap them. So I will take and if you want me to tell you approach, I will tell you the approach like this. See, when I have taken P1 as false, P2 as both P1 and P2 to be false, and I will put it here, I will say immediately it will become false. So let me try. I will put it here false and here true, so that I get true here. So P2 should be true. P2 I will take it as true. Now as soon as P2 I am taking to be true, so Q2 should be false now, because I have to make it as false. So Q2 is false, Q1 is true. So finally what I am getting, false or true is true, true or false is true, true and true is coming to be true, and this is coming to be false. So I have given you one case where this is true and this is false. So clearly this formula is not a valid formula, or you may say it is not a tautology. It is a bit difficult kind of thing. If you try to follow it, you will obviously get it. If you still have doubt, you can rewind the video and watch it again in the recording itself. Please take snapshot. I will jump to the next slide because I will keep on showing you here proof and all. It will waste our hell lot of time. If somebody is feeling that I am not able to get even 40-50% of it, then obviously I will explain it again. Please let me know if anybody is having any doubt.
Clear, sir.
Okay, then let me jump to the next slide now. Okay, it's just your practice. It's hit and trial, clearly hit and trial. Keep on doing practice and practice, you will get more clarity. Okay. So finally, what I have told you, the resist is not distributive over and why it is not distributive? Because this was coming to be true, but this is coming to be false. That's why the resist is not distributive over and. Please take snapshot. I will jump to the next slide. Okay, now I'm jumping. So next is for all x, px or qx implies this. So same scenario, same. You make this as true, this as false, game is over. So let me try to do it. So for all x, px or qx. So how you will expand it? Let me use a different color. P1 or Q1 and why and because of for all. P2 or Q implies P1 and P2 or Q1 and. So what is our aim here? So our aim is to make this as true and this as false. If we are able to do it, game is over. So how you will make this as false? So you consider any one of them to be false or both to be false. Only then it will be false. Sorry. Uh, to make it as false, you have to take both of them to be false. Only then. Only one case is there. No, only one case is there. You consider both of them to be false. And how you will make it as true? Only one case, both should be true. Okay, so I think same way. So work should be minimum. So we can start from here also, from here also. It's our wish. So let me start from here. Okay, so to make it as false, I have to make this as false and this as false. To make this as false, there are many possibilities. Rather, three possibilities are there. So only one possibility where it will be not be false when both are true. So obviously, I will not consider both to be true. So to make it as false, do minimum work, one to be true, one to be false. So P1 is true, P2 is false. Similarly here, I will take Q1 to be true, Q2 to be false. As soon as I take it, I will put the value here. P1 to be true, Q1 to be true, P2 to be false, Q2 to be false. So true or true is true and P2 or Q2, this is false. So true and false is false. So I'm not able to make it as false. Sorry, I am not able to make it as true. So how I can make it as true? So I will think like this. I will do it minimally. P1 to be true, Q1 to be false. So let me take another values. This is true, this is false. And this is true, this is false. Let me do it now. P1, P2 to be true. Can I do it? P1, P2 to be true. So true, true. And uh, Q1, Q2 false. Q1, Q2 false. Yes, I can do it. Q1, Q2 false. So true and true will be true or false and false. So true and true will be true. False and false will be false. True or false will be, oh sorry, true or false will be true. Nah? I want here false. Yes. So I cannot do it. I think you have got it. I cannot do it. So, and if you can consider more cases also. Okay. But by intuition, I think you have got it. We cannot do it. Okay. So you just try to do it in at your home. Okay. So make this as true and make this as false. So no way out. There will be no way out. So and in fact you can swap them also. So this is true, this is false, or you take this as false, this as true. Okay. Let me do one more case for you. So I'm taking P1 to be true, Q1 to be false, P2 to be false, Q2 to be true. P1 I am taking as true, P2 I am taking as false, Okay, Q1 I am taking as, yeah, I have done it. Sorry for that. I have done a mistake. So I have just flipped them and I am getting the answer. So P1 is true, P2 is false, Q1 is false, Q2 is true. Yes. So true and false is false, false and true is false. So false or false is false. And this thing is true. So this is true, this is false, I have done it. So clearly this is not a valid formula. This is not a valid formula. So you have to just develop thinking here. Okay, and what was the key idea here? So I want to make this as false. So in order to make this as false, I have taken this as true, this as false, this as false, this is true. And when I substitute these values, I have got the answer. Okay, please take snapshot. I will jump to the next slide now.
So the last which you wrote in black color, true and false and true in the first left hand
Mhm.
side. So,
Mm-hmm.
so that results into false, no?
Yeah. So this was giving us
No,
a
not
false
left hand side, sir.
left hand side. Okay. So true or false is true.
Okay, sir.
False is true. True
True.
and true. So it's completely hit and trial. Okay. But if you do lots and lots of practice, you will get clarity and you will be able to solve gate questions very easily. It's my guarantee. Okay. You will be able to solve them very easily. So it's all about your way of thinking. How you think, you will get more clarity. Please take snapshots. So two ways I failed, but in the third way I passed it. Okay. Finally, it was not valid. Okay, let me jump to the next slide. So this thing. So clearly, let me do it. For all x px. So p1, let me expand it, p1 and p2, or q1 and q2 implies p1 or q1 and p2 or q2. I think you have got it, na? P1 and p2, q1 and q2, p1 or q1, p2 or q2. P1 or Q1, why? Because for all x was outside, that's why. P1 or Q1 and Q2 or Q2. Yes. So to make it as false, true and false. So I have to make this entire thing to be true and this entire thing to be false. So first of all, I will see where work is minimum. To make it as false, I can consider any one of them to be false. Okay, so three cases are there. Similarly, to make it as true, I can consider any of them to be true. So clearly, three cases are there. So both are demanding more work from us. Both are demanding. So we can start from anywhere, whatever way we want. So let me start from here. Let me make it as false. So to make it as false, so what should be done? So minimum work should be done, na? So to make it as false, I will consider one of them to be false and one of them to be true. Because minimum I have to do. I will consider this entire thing to be false and this entire thing to be true. Now to make this as false, the only possibility is P1 should be false, Q1 should be false. Okay, only then it will be false, na? Because if even one of them is true, then it will be true. Okay, yes. So P1 and Q1 are false here. So let me put the value here. P1 is false, Q1 is false. As soon as I put the value, I will forget about P2 and Q2. I will finally get both of them to be false, and finally I am not able to do it. That is one of the case. Okay. So now I think you have got clarity. If I try to make this as false, this and true, same thing. Let me do it with another color. I think you have got the idea. If I make this as false and this as true, same scenario. To make this as false, now see this. Why I have concentrating on false? Because to make it as false, only one scenario. To make it as true, three scenarios are there. But to make it as false, only one scenario is there. So try to do minimum work. So to make this as false, what are the possibility? only one possibility, P2 and Q2 both should be false. The moment P2 and Q2 are false, this will be false. Let me write it downward. This will be false and this will be false. Immediately I will forget about Q1 and P1. It will finally come out to be false. So there is no way out. There is no way out to make this is true and this is false. So clearly this will be a valid formula 100%. I hope I have made the point clear. Please take snapshot. I will jump to the next slide.
Done, sir.
So finally, summary is what? There exists is distributive over all, for all is distributive over and, there exists over and no, for all over or no. Yes. I think I have given you summary already. Let me jump to the next slide now. Now question arises, for all is distributive over implication or not? There exists is distributive over implication or not? Let me show you. So for all is distributive over implication. So how you will say? I will say for all x, px implies qx is equivalent to for all x, px implies for all x. I think you have got it now. For all x, for all is distributed over implication. I will write like this: for all x, px implies qx, that is equal to for all x, px implies for all x q. Let me expand it to get more clarity. So I will expand it. So I will say p1 implies q1 and p2 implies q2. I think you have got it now. P1 implies q1 and p2 implies q2. Is this equal to saying that P1 and P2 implies Q1 and Q2? I think you have got it. So now they are equivalent or not? So how we will do it? So simplest way is convert into Boolean algebra. You will get the clarity. P1 implies Q1. So P1 bar plus Q1 dot P2 bar plus Q2. Is it equivalent to P1 P2 bar plus Q1? Clearly they are not equivalent. I think you can guess it because it will expand to P1 bar plus P2 bar plus make Q1 Q2, and you can expand it yourself. You will not get it. P1 bar P2 bar, you will be getting P1 bar dot P2 bar, and here P1 plus P2. So clearly they are not equivalent. So for all is distributive over implication, this statement is false. There exists distributive or implication. Let me show you in the another slide. I'm jumping to next slide. Please take snapshot. Only 1 minute. I will take just 1 minute. I know the time is up, but I will take just 1 minute.
I would like to take the screenshot of the last slide also.
Okay, you can. Yes, we can.
Yeah. Done, sir.
Okay, this thing you have done. Okay, so now I will just show you. Okay, so actually you can do it in homework also. Okay, let me leave this as your homework.
We'll do it, sir.
Yes, good. So try to do it in your homework, and in the next class we will resume from here itself. Okay.
So I had a doubt.
Yeah, you can ask me.
I'm sorry if I'm taking your time.
No problem.
You can off the recording, sir.
Okay, no problem, and others can also listen. The doubt is from which subject?
All right, sir. No. The doubt is like I'm not getting how to initialize taking tests, sir. Mock tests.
Okay, then let me off the recording first. Okay.
Okay, sir.